Hello, everyone, and welcome to our webinar on the climate and cost advantages of switching to a cold weather air source heat pump. We're just going to give it another minute or two to let people join. We do have a very large crowd tonight, so we will begin in just one moment. My name is Brad Cundiff, and on behalf of the OCAA, I'm your host for tonight. However, I will not be serving drinks. The Clean Air Alliance is working hard to draw attention to climate-friendly alternatives to increasing the use of fossil fuels in our electricity sector. And we think heat pumps are a great one, which is why we're so excited about the event tonight. So you can find out more about our organization and its central role in ending the use of dirty coal in our electricity sector and on our website at cleanairalliance.org. Before we begin, we would like to extend our respect to all Indigenous peoples for their valuable past and present contributions to this land. We acknowledge the waters, air, lands, and resources that continue to create safe space for our gatherings, our workplaces, and our homes. And we recognize and respect the importance of Indigenous leadership in protecting and stewarding the land. So we are really pleased to see the very high level of interest in this topic, and we hope you're going to learn a lot tonight about this exciting technology. We have a couple of housekeeping things to cover first. You'll notice that cameras and microphones are off for everyone other than the speakers and a few other important folks who I'll explain in a moment. We've also disabled the chat function because we have such a large crowd, which means that you need to ask questions through the Q&A function. The webinar is being recorded, and we will be posting that recording later this week on the Clean Air Alliance website. We will also post the Q&A, or at least a selected part of the Q&A with usernames blocked out on the website along with the recording. We have allocated 30 minutes for presentations, and then we will try to get to as many questions as we can after that. As I said before, to ask a question, please use the Q&A function. However, we do suggest that you might want to listen to the presentations first, because hopefully they're going to answer quite a few of the questions that you might have. We have some additional experts online today to help answer questions as we go along. I'd like to thank Eric Jansen from TRCA STEP program, Keith Burrows from the Atmospheric Fund, and Victor Hyman from Climate Care for helping us respond to your questions. Even with all these great minds, we won't know the answer to every question, so please bear with us. And keep in mind that what we're trying to do tonight is to provide some general overview of the technology and not specific installation instructions for your particular home. I just also need to note that involvement in this webinar or any mention of a company, service, or product does not represent an endorsement of such from any of the organizations involved. We strongly recommend talking to friends, neighbors, and others and doing your homework before selecting any product or contractor. Okay. So we're almost there. We have two great speakers tonight who will be covering slightly different aspects, but both have a lot of knowledge about heat pumps, including firsthand knowledge from their own personal heat pump installations. So our first speaker is Heather McDermott, is the founder of McDermott Climate Consulting, which specializes in research work related to decarbonizing the residential sector. Heather has authored a few reports on the economic and climate benefit of heat pumps from the OCAA, and you can find those on our website. And she's going to talk a bit about what the technology is and the dollars and cents of switching. So now I'm going to hand it over to Heather.
There we go. And so my name is Heather McDermott from McDermott Climate Consulting. And as Brad noted, I specialize in decarbonization solutions for the residential sector. And I'm very excited to be talking to you today about one of my favorite technologies, which is heat pumps. So just starting off, what are heat pumps? They are equipment that move heat to keep a space warm or cool. And because they're moving heat rather than generating heat, they're capable of being extremely efficient. So if you have a gas furnace, for example, the maximum theoretical efficiency that you can achieve with a gas furnace is 100%, because you can't get more heat energy out than the energy contained in the fuel. But because heat pumps are moving heat, they can be 300, 400, even 500% efficient. They're using energy to move the heat, not to generate it. Heat pumps are reversible, so you can use them to cool your space in the summertime, moving the heat out of your home, and you can use them to heat your space in the wintertime. And you have several heat pumps in your home already. Most of them are working in just one direction. That's your fridge, freezer, and air conditioner. And many people are concerned that heat pumps won't have the ability to keep their home toasty warm on the really cold winter days. And I like to say, do you trust your freezer? Because your freezer is keeping your food at about minus 18 degrees Celsius. And it's doing that in a room that's about plus 20 degrees Celsius. So your freezer is able to extract heat from food inside that freezer and move it into a room that's already significantly warmer. And if you trust your freezer to be able to do that, you should trust a heat pump that is designed for cold climates to be able to heat your home. So there are several different types of heat pumps. The one that we're going to be focusing on today are air source heat pumps. And they've come a long way since the heat pumps that my parents installed in the 1980s. So and you can still buy heat pumps that are similar to those. Those are sort of the conventional heat pumps. They don't operate very well at very low temperatures. They're not designed that way. And so you need a secondary heat source if you're going to use those for heating. But just as cars have really developed a lot since the 1980s, so have heat pumps. And modern cold climate heat pumps are capable of operating at minus 20 degrees Celsius, even minus 30 degrees Celsius or lower. And even if you live in a very cold climate, if you're up in Thunder Bay or Ottawa, you may also have a backup electric resistance heater that can take over if the cold climate heat pump starts to struggle to keep up. But absolutely, those cold climate heat pumps can provide just about all of the heating that you need. The other main type is the ground source heat pump. So instead of extracting or depositing heat in the air outside, they're extracting heat from the ground. And so you have loops down below the frost line, either horizontal or vertical, and they're either extracting heat from the ground or depositing heat in the summertime in that ground. And because that's below the frost line, the temperature is much warmer than it is outside in the cold days, and they can be much more efficient. So these are the types of systems where you can see 500% efficiency. There are also heat pump water heaters that can provide the hot water for your showers and your dishwasher, etc. And there are very similar to that, there are air to water heat pumps. So that is the type of system that you would be looking for if you currently have a boiler system and radiators. But we're going to focus today on the air source heat pumps, the air to air. This is some images of what they look like. So the outside unit either looks like this box on the bottom with a big fan, or it looks like your air conditioner, because it basically is an air conditioner that's just reversible. That's the outside unit. And if you have ductwork in your home, then the inside unit looks like what you have in the top right there. It looks just like your furnace. So there's the inside unit there and the air handler that's just pushing the warm or cool air through your home. If you don't have ductwork, then what you're looking for is a mini split or multi-split system. It has the same outdoor type boxes. And on the inside, you have these cassettes that blow warm or cool air. They can be mounted in the ceiling, on the top of the wall, or in these boxes that are sort of on the wall, sitting on the ground. And then this is what a heat pump water heater looks like. So it looks pretty much the same as an electric tank water heater. It just has an extra bit on the top where the heat pump is working. And you're probably hearing a lot about heat pumps these days. And the main reason for that is because heat pumps are our #1 solution for decarbonizing buildings. In fact, it is the top solution recommended by the IPCC, that's the Intergovernmental Panel on Climate Change, and the International Energy Agency, both of which are huge international organizations with lots of really smart people working in them. But it's also the top solution recommended by most climate action plans, including most likely the climate action plan in your municipality. And that is because heat pumps are the most energy efficient heating systems out there. As I noted, you can't get more than 100% with a gas furnace, but you can get 300% with an air source heat pump. And because they are the all electric versions, can run on fully decarbonized electricity, so you can achieve zero emissions with heat pumps. Oftentimes, they're the most economical solution. So these are the systems that are going to be saving you money. And of course, they're a proven technology. The first heat pump that was ever invented was somewhere in the mid-19th century. So they've been around for a long time. If we're looking at Ontario specifically, heat pumps can reduce emissions by 35 to 45% right now with the current grid, but that will rise to about 100% when our electricity is fully decarbonized. And the federal government has committed to achieving zero carbon electricity by 2035. What's really key is that we need to start shifting in large numbers to heat pumps now. And that's because heating systems last for 15 to 20 years. And we need to ensure that by 2050, we have a net zero emission society. And decarbonizing buildings is one of the simplest and most economical things that we can do. It's also, as I said, in Ontario, one of the most economical things that you can do. So in a report that I did for the Ontario Clean Air Alliance, we looked at the lifetime cost for different systems for an average home in Toronto. And here we're looking at the lifetime costs for a home with gas furnace, gas water heater, and air conditioner, and a home with a cold climate air source heat pump and a heat pump water heater. And as you can see, the upfront cost for the heat pumps is significantly higher than the gas-based systems. And those costs are coming down, but you can recover those costs within X number of years because the operational costs are significantly lower. So that light green bar, part of the bar, is showing us the 15-year heating costs for these systems. And with the heating costs alone, you're already saving money, but you're saving money as well on the cooling costs because heat pumps tend to be more energy efficient than regular air conditioners. You're saving a lot of money on the water heating costs. And bonus, if you're able to disconnect from the gas system, you can save an extra $300 per year in gas connection fees. And so there's about $10,000 difference between those two scenarios in a Toronto home. It's about the same in other parts of Ontario. We modeled it in different cities across Ontario. And since we did that analysis, gas prices have gone up and electricity prices have come down. So gas prices went up again October 1st. Gas prices are going up again January 1st. So we also looked at a variety of different scenarios. So this is the lifetime savings from space and water heating, electrification with heat pumps. The green bar at the top is the baseline I just walked you through in the last slide, but you get even more savings if you're in a larger home that has a higher heating load. You get a bit more if you only switch to a heat pump for space heating, but kept a gas water heater, but you still got those significant savings. You get a bit less than the baseline if you used an electric resistance tank water heater instead of a heat pump water heater. It costs less upfront, but it's going to cost you more over its lifetime to operate. We assumed that carbon taxes don't rise after 2030, but there are many groups that are anticipating that it will. So we modeled that, and you see with taxes rise, so will your savings. If you install a bit later, you also get slightly more savings because the carbon tax is rising progressively. And most importantly down here, if you happen to live in a gas expansion community, connecting to the gas supply is not in your best interest. And that's because you're paying an extra 23 cents per cubic meter for your gas to pay for that gas expansion. And in those communities, we're seeing more of a $20,000 lifetime savings. We also looked at the savings potential for shifting homes that are currently heated with electric baseboard or electric furnaces to heat pumps. And you can see the lifetime costs here for electrically heated homes. If a home has ductwork, then we're looking at something like $30,000 in savings over a 15-year lifespan. And if the home has baseboard and is heaters and is using multi-splits, then the savings are more like $15,000 over the lifetime. So significant savings there as well. And if you were just curious, so there are 3 reports now available from the Ontario Clean Air Alliance. They're all on their website that go into what I was just talking about in more detail for air source heat pumps and gas heated homes and electrically heated homes and for ground source heat pumps. I encourage you to go and have a look at those. And if you happen to be heating with heating oil, propane, then your savings are also significantly higher than what we showed there. There are several incentives available to help cover address the upfront costs of heat pumps. So the Greener Homes Grant, up to $5,000 is available for a cold climate air source heat pump. You can also get up to $40,000 in zero interest financing over 10 years. And yes, you can get both of these. In addition, there are many municipalities that have developed financing programs to help cover those upfront costs. So these are the names of some for Toronto, Ottawa, and Kingston, but the Federation of Canadian Municipalities is supporting many municipalities in Ontario in developing their own programs through the Community Efficiency Financing Program. So I encourage you to reach out to your municipality and find out where they're at in that process. And finally, I wanted to draw your attention to the fact that the Ontario Clean Air Alliance has developed an online calculator that can help you to estimate your savings when switching from gas to heat pumps. And in order to use this calculator, you want to dig up your annual gas use. So you should be able to find that online for your bills, and that will give you some idea of what type of savings you can expect. So that's what I have to share with you today, and I'm going to be passing you on now to Gil, who's going to talk about some actual live case studies that they've done in the Toronto area with heat pumps. So on to you, Gil.
Thanks, Heather. I'm just going to intervene here and introduce Gil. And also, I just want to note that as well as Heather's reports, her actual working spreadsheets are posted on the OCAA site. So I see a number of questions about this permutation or that. Those spreadsheets allow you to test various scenarios, change prices, adjust for different areas. A great tool as well. They're in the publication section. So just look, they're posted along with the reports. So next up, we have Gil Amdursky. Gil has been a technical coordinator on heat pump pilot projects for the Toronto Region Conservation Authority's STEP program for 10 years, evaluating the real-world performance of the technology. And Gil is going to share some findings from recent case studies and talk about some other options, such as hybrid systems. So over to you, Gil.
Thank you very much, Brad. Can you hear me okay?
You're good, Gil.
Okay, thanks. Yeah, so thanks again, Brad, and thank you very much to Heather. Very informative webinar presentation that you had there. Lots of interesting numbers and lots of interesting facts, so thank you so much for that. Thanks for the introduction, Brad. My name again, it's Gil Amdursky. I'm the technical coordinator for the STEP program. And so today, for the latter half of the presentation, we're going to be focusing on some actual case studies and some real world installations that our group has evaluated. So yeah, again, today we're going to talk a little bit about our organization, STEP, and the goals for today. And then we're going to look at data and experience from actual retrofits. So some ductless air source heat pumps and centrally ducted cold climate air source heat pumps as well as hybrid heating retrofits. And for those of you not familiar with some of those terms, they will hopefully become a little bit more clear as we go along here. So our group STEP, the Sustainable Technologies Evaluation Program, we are a group out of the Toronto and Region Conservation Authority. We are a not-profit collaborative research organization. And the main thing that we do is we evaluate technologies in real world instances. So the image shown here is the Archetype Sustainable House, which is a show home for sustainability. But we also put real equipment in this home, as well as other buildings in and around the GTHA, and we evaluate their performance. So the goals for today. We really want to demonstrate that air source heat pumps work in our climate, and generally they perform near the expectations in terms of energy and utility savings. That there are heat pump options for every home. There's a myriad of different technologies and technology archetypes that we will describe some of them. There are both budget options as well as high performance options, which may be a bit more higher in price. They do have the capability to pay for themselves. This is again dependent on many different factors, which we'll go over some of them. And that homeowners are generally satisfied with heat pumps, at least in our case studies we found. So this is the first case study we want to talk about, evaluating ductless air source heat pumps. So this was a case study that we conducted in a rental townhome, a row home in Brantford, Ontario. The buildings and the houses were heated with electric baseboards. They had no central cooling. So some funny things happened, like you see in the little picture here, you see some what I like to call window shakers or window air conditioners. And these can be problematic, especially in wintertime with infiltration. They could also be dangerous as they could fall out of the window. So these were 2 and 3 bedroom units, and we can talk a little bit more about our findings here. So we retrofitted 4 of these townhomes with ductless multi-split air source heat pumps. Heather described this type of system a bit earlier, but here in the large picture of the outside of the house, you can see what the outdoor unit looks like. And then you can see the refrigerant lines running around the outside. And you can also see the indoor unit on that indoor picture. So it's not that invasive, if you will. There's no ducting on the inside. The only thing on the inside is these indoor units shown here. We saw an annual savings of approximately $850. The upfront costs were a bit high. We think this particular case study happened a few years ago, but we think the prices are almost the same right now. At the time, there was no rebate. Right now, there are rebates, as Heather mentioned before. So with that rebate, the federal loan and the grant program, we expect that there would be net overall cost savings. But that, after a certain time period, like the 10-year loan period, you would be savings. Like you would be buying out the system, and then you would be able to amount some savings after that. Note that energy savings was good with this study, but lower than expected due to a number of different factors. So we had, the homeowners, using the systems in different manners. We had some installation issues. So there's a whole bunch of different factors there. So just in terms of the feedback, so these were from the actual tenants within this study. Some of them said that, you didn't even know that it was on. It was so quiet, that they were just generally very happy with it. It was far better than before. And now they actually had cooling, which before some of them didn't have cooling. And that it did more than enough and performed very well. The next case study I want to talk about is evaluating some central cold climate air source heat pumps. So we have 2 studies where we evaluated actual homes. So these were 2 Century homes actually in Toronto. So we actually looked at real data. So we evaluated pre and post retrofit utility bills in these actual installations. This was before the Greener Homes grant and loan. So some of the costs might be a little much, but that's because they weren't able to utilize that grant. They both used premium cold climate air source heat pump equipment. They had a complete all electric replacement of gas furnace and air conditioning system. In one case, there was a conversion of hot water as well to a hot water heat pump, similar to the one that Heather mentioned in the previous slides. In general, the systems cost approximately $20,000. And then there were some additional ancillary costs. There were some electrical service upgrades. A lot of these homes were these homes in particular were a bit older, and so they had 100 amp services, and so they had to upgrade to 200 amp services. In the case of the conversion to hot water, this was an additional roughly $6K costs, as well as they had they had like a mini split in the 3rd floor because they had some ducting issues or some heat cold issues. So just to note that cost varies a lot between home to home. And keep in mind, these are, premium top of the line central cold climate air source heat pumps. So probably the most expensive in the market. In terms of the savings, there is a high uncertainty with estimated lifetime savings. Well, I say high uncertainty because we really don't know what the utility costs are going to do. There is some speculation. Electricity is sometimes a bit better estimated, but we don't really know what those costs are going to do in the future. So all we can do is estimate as best as we can. So generally, the system is expected to pay for itself with the current gas rates and the current programs that we have. There are good or decent results in older homes. Better results can be achieved in newer homes where you may have a tighter envelope, better insulation, better codes and standards. Just to note here, the orange part of the annual utility savings is a gas customer charge. So if you were to completely remove all of your natural gas usage and cancel your natural gas account, there's approximately $250 to $300 a year that you could be saving there. Just generally for these cold climate air source heat pumps, very good feedback. Both of the case study homeowners said that the machine works well. Thermal comfort has significantly improved, and they say that some of the costs are the same. Like in the summertime, it costs the same as their air conditioner, and so generally very positive results and feedback from this. Switching now to hybrid heating. So there are plenty of scenarios where homeowners might be interested in technologies other than cold climate air source heat pumps, like we just described, such as maybe the home has a newer furnace, so you're reluctant to replace that new furnace. Maybe you need lower upfront costs. Maybe you can't stomach that $20,000. It's a bit of sticker shock, if you will. It could be possible that the ductwork is undersized, and so a smaller hybrid system might be beneficial. There are instances where the electricity is constrained. We mentioned before that some of those older houses and some townhouses actually only have 100, or some even only have 60 amp services. Or there's a need for an emergency replacement. So another option is a hybrid heating system, which utilizes both gas as well as an air source heat pump. The air source heat pump would do all of the cooling, replacing your air conditioner, and a majority of the heating system as well. In addition, this type of system can use an existing furnace. So here's a bit more background on that. So hybrid heating can have lower upfront costs than fully electric, such as those cold climate air source heat pumps we mentioned before, but it can maintain many of the benefits. The air source heat pump would be used for the milder conditions, and the furnace would be used for extremely cold conditions. In Southern Ontario, which is where this data in this image is from, most of the heating energy is actually in milder temperature. Extremely cold is actually very rare. So in this image here, we show you that most of that heating system is here. I believe our point is like -8. And so a majority in this image, I believe it's over 75%, is above -8, warmer than -8. And it's even possible to use an existing furnace as an air handler. So here's some of those case studies I promised to be able to support some of this information. So we have 3 case studies of 3 homes within the GTA. Again, we evaluated utility bills before and after this retrofit. So we actually used real data. The installed costs for these combos, furnace and air source heat pump hybrid condos, were about $8,000 to $10,000, but we've seen that they could be up to about 12,000, if not a bit more. They used single and two-stage heat pumps, so no inverter-driven technology, which can be a little bit more expensive, but also more efficient. Inverter-driven options are available. In general, this system setup could be as low as $1,000 more than a standard furnace and AC combo. So if you were to buy a furnace and AC combo right now, it could cost you, I don't know, 6 to 8 or maybe even 10K, depending on where you are or what your system size is. But you saw from the numbers that we showed here, these systems were about 8 to 10,000. They had the capacity to reduce gas consumption by 50 to 75% within these 3 case studies. And energy savings was near expectations based on the equipment ratings. Here we can show you a little bit about the gas savings. So this is some updated data using current utility rates and factoring carbon pricing until 2030. So here we could see that the simple payback versus the traditional gas furnace without any rebates, the gas furnace that is, it could be several years. And these numbers would change, they would be much better against propane or oil. As Heather earlier showed, those propane and oil prices to be much more. Just general feedback again on these hybrid heating systems. The homeowners were happy with the contractor's work. They found the system more comfortable. They did see some slight overall savings, and that they were actually very quiet and no noisier than they were before. Some final things to note on the hybrid heating. This has been used for many years and also used as a way to lower natural gas for many, many years. Air source heat pump costs vary greatly, although there are budget options as well as high performance and more expensive options available. Different control options can optimize for the lowest cost or the lowest carbon. So depending on how you want to operate it, if you really want to save as much greenhouse gas or as much carbon as possible, then it might be slightly more expensive. Enbridge is currently running a 100-home rebate pilot in London. All those systems are installed, but they're currently monitoring it. A 1,000-home rebate is coming soon. That one was already, I believe, presented in the news. So I believe that's coming any day now. Our group actually has a small incentive program for hybrid heating. If you are planning on keeping your furnace and replacing only your air conditioner, and you live in Peel region, you could incentivize that install at the tune of $2,000. That is limited, and there's the link for the program there, and maybe someone can include the link in the chat. And federal grants also cover some high performance hybrid systems. See, I'm taking too long, so I'll try to wrap up real quick. So just revisiting the goals for today. Yes, air source heat pumps do work in our climate, and generally they perform near expectations in terms of energy and utility savings. There are heat pump options for every home. We've talked about a few, but there are many more. There are both budget options as well as high performance options, which may be a bit more expensive. They do have the capability to pay for themselves, and that most, if not all, the homeowners that we've surveyed are very satisfied with their heat pumps. If there's one thing you could take away from today, it really no longer makes sense to install an air conditioner to buy a new air conditioner, at least choose a heat pump. It can do the same thing as your air conditioner, and then much more. And you can learn more about our program. We also have an air source heat pump campaign with these case studies on that campaign website, and maybe somebody can include the link so that the audience can visit that. So thank you very much. Thank you to our partners and sponsors within the campaign and the case studies, and thanks to our homeowners. And a little bit over time, so back to you, Brad. Thank you all very much.
Thanks, Gil. That was very informative. And I think, a quick overview that there are a bunch of different options out there. It is important to note that the Greener Homes program, the federal program, does have that zero interest financing, which can be very key to overcoming those somewhat, high upfront costs. And I think, some of the math suggests that your savings on your monthly utility bill could be more than your loan payments with that zero interest financing. Bit of a torturous path to get it all through the hoops, but it is there, and it's the kind of program that we need to see a lot more of, and it would be nice if the province stepped up perhaps and matched something like that. So I see our team has been doing a great job of answering questions, but I want Gil and Heather to pop back in here because I'm going to highlight some sort of common questions. One of which I think is just, the technology seems a bit magic to some people. And I know Heather explained it a bit, but there's still the question of where does the heat come from? How do you heat without burning something?
Yeah, maybe Heather did a good job explaining it before with the refrigerator. I mean, that's usually my go-to. I mean, I either talk about the refrigerator or something that most people already have, which is an air conditioner. So if we can think about, very simply look at the thermodynamics. I know that's a very scary word, but of an air conditioner, you're removing energy. You have a box, which is your house, and you have that little air conditioner outside. You're essentially removing energy, removing heat energy, and you're dumping it outside. So, on a hot day when your air conditioner is working, if anybody's done this, you go over top of your air conditioner where that fan is blowing, and you feel that really hot air, like it's really hot. And that's because it's rejecting heat into the outside air. So it's taking heat from inside of the enclosure, your house. It's removing that heat, therefore making your house colder, and then it's rejecting it outside. So if we could, let's say, do the opposite of that, which is what a heat pump can do, let's now go to winter. In the wintertime, it's cold outside. You want to make the inside of that enclosure now hot. People might not think about it, but there's still heat in the cold. There are liquids called refrigerants, which can boil. They absorb heat. So even in really cold temperatures, -20, -30, they can absorb the heat from the outside, and then they reject that into the enclosure, your house. So that's one way I like to think about it. I don't know if that helps anybody, but also the fridge is a very good example, right? I'll try to make this very quick. You have a fridge. You have the inside of the enclosure is where it's cold, and for those of you who remember the really old fridges, it kind of had a coil in the back. You could actually feel the heat on that coil. That is heat being removed from inside of the box. And so just like in the winter air source heat pump example, even though you don't think there's heat in your fridge and in your freezer, there actually is. And that heat is being removed and kind of rejected out the back of that fridge freezer. So that's another example. I don't know if that helps to demystify it.
Great. So you touched on refrigerants, and there's been a couple of questions about refrigerants and what is used in heat pumps and whether there are climate-friendly refrigerants in use in heat pumps and what the implications are. And I don't know who's the best to answer that. Heather,
I
do you
have
want?
some great examples for that one. So the good news, so the bad news is that refrigerants have a very high global warming potential. So if your refrigerants leak, then they are several thousand times worse than on a molecular basis than carbon dioxide. But there's some good news there too. First of all, there isn't a lot of refrigerant in a heat pump system. And if the installation is done by a professional and it's done well, then it shouldn't leak. We're also shifting to new refrigerants that have low global warming potential. This is due to the Kigali amendment to the Montreal Protocol, which was brought in because we were concerned about the ozone depleting aspects of refrigerants. So we are transitioning to some of these better refrigerants. But then the question sort of becomes, if these are such terrible things and a disastrous leak does happen, how bad is it? And I've got two examples for you. The first one, there was a study done in the US that demonstrated that in many cases, the global warming impact of a refrigerant leaks is less than the global warming impact of behind the meter methane leaks or behind the meter natural gas leaks. So if you're connected to the natural gas system, it's not, there are leaks in the system. So every time your gas furnace turns on, a little bit of methane escapes. And methane is also many times more potent than carbon dioxide. So you're still better off with a heat pump than a gas system. I also went and did a calculation for my own home when I put in a heat pump. And I made estimates as to how much refrigerant was in my system, and then looked at how long would I have to operate my heat pump in order to compensate for the emissions impact if all of that refrigerant leaked. And for my home, that was 2 years. So I've now run my heat pump for 2 years in my home. And if tomorrow there was a catastrophic leak and all the refrigerant got out, my home would be responsible for the same amount of emissions as if I had been running a gas furnace. So yes, these are terrible chemicals when it comes to climate change, but it's still the better option to go with a heat pump.
Thanks, Heather. That's
Bill,
great.
Anybody else have anything that they want to add on to that?
I think that's good. There's been a couple of questions about icing up and defrost cycles, and I wonder if somebody can address, the frequency of that and how much of a concern it is.
Over at the Archetype Sustainable House that we showed a picture of before, we've had air source heat pumps, cold climate air source heat pumps running from the inception of the house, which is about 13 years ago now. Never had an issue. That's not just one system, that's with almost a dozen systems that we've had in and out of the house. My own air source heat pump that I have at home, I haven't had a true deep cold to be able to answer that. Heather, I don't know if you have. I know that some units you can actually specify an additional heater on the bottom of the pan, like an electric coil. Whenever the defrost happens, I believe that heater also runs. I don't think it's really necessary. I don't know if Victor or Heather has anything to add to that.
Yeah, when it's defrost often runs not in the really cold temperatures, but in the in-between temperatures where it's humid outside, and you get a lot of condensation on the coils outside. But there's sensors in the heat pump that detects when there's a lot of frost buildup, and then the heat pump just reverses itself for a very short period of time. So it's sucking a bit of heat out of the home
to melt all that frost on the outside so that the heat pump can continue to operate efficiently. And in many systems, it might turn on your backup resistance heater while it's doing that so that you don't get cold air blowing into your home and you stay comfortable. Victor, did you have anything to add to that?
Yeah, that's a great explanation, Heather. I would just say it really depends on the system. Some systems will turn off the indoor fan entirely, so it doesn't blow any air on the inside. And it will just run the compressor. So the heat of compression will be used to defrost the outside coil. And Heather, you're 100% right. It's actually, icing up isn't an issue when it's really cold, because when it's really cold outside, there's less humidity in the air. It's actually when it's moderately cold, so -2, -3, -4 degrees and humid, that they do tend to ice up. The most important point I would say is to make sure that when you're installing it, when your installer installs it, and they should know this if they install heat pumps, to install it at least 30 centimeters above the anticipated snow height. I saw there was a question in the Q&A about snow drifts. That is an issue. And so if you know that you get snow drifts on that side of the house, you want to make sure that the unit is installed above the anticipated snow.
Good point, Victor. Okay, older homes and suitability and just generally, should you insulate first? And is there could you end up oversizing your heat pump if you don't? And just the general practicality of an older home situation. I think, Gil, you touched on the idea that, it is a bit more of an uphill climb in an older home.
Yeah. So I would always recommend the first step towards sustainability, if you're looking towards your own home, is get an energy audit. So one of the things, in order to participate in the Greener Homes Grant, which hopefully we have a link to somewhere, you have to do the first energy audit. And that energy audit will basically let you know, you do or don't have enough insulation, or adding this much more insulation is going to make your home heating load that much smaller. And therefore, you might be able to get a smaller heat pump. So I would say that's the most beneficial thing to do in the first place, is get that energy audit done. And you get, I believe you get the cost of the energy audit paid for if you participate within the Greener Homes program. So it's essentially free.
Anything to add to that, Heather?
It's a bit of a toss-up, I think, in sort of what, in my opinion, as to how much you want to delay installing a heat pump in order to do building energy efficiency upgrades. So there are many building energy efficiency upgrades that you can do that are fairly simple and cost effective, and absolutely do those first. But it might, from a climate standpoint, it might not be a good idea to delay installing a heat pump for 15 years in order to do some extra insulation in the walls, for example. So there's a bit of a trade-off there. If your furnace is coming to the end of the life, then you should be thinking about looking into a heat pump and talking maybe with your energy advisor about what might be some good steps moving towards that. We do need to urgently start shifting away from dependence on fossil fuels if we're going to meet our climate targets and keep our climate safe for future generations.
All right. Well, while I have you, Heather, are heat pumps suitable for multi-residential buildings?
Absolutely. And I think, Gil, that you've done some work in some multi-unit residential buildings. So it again depends on what type of heating system that you're starting with, but I'm aware of several multi-unit residential buildings that have shifted towards mini split heat pumps. But Gil and maybe Keith as well has got some.
Yeah, there are, Keith actually might be better to answer this, but there are lots of options for all different building types. Keith.
Yeah, and I'll just say that we've installed over 300 units in multi-residential buildings. and they're working great. No backup with these systems, so they're providing 100% of the heat, and residents are happy. These have been primarily, what we've done is to this point have been multi-split systems, but we're also working with Gil on a larger air to water system that we're really excited about, but definitely applicable to that building type.
Okay. So I know we've touched on this in the presentations, but I just want to, again, is it absolutely necessary to upgrade to a 200 amp service? And under what circumstances is that going to be mandatory?
It really depends on what your loads are to begin with. Do you agree with that, Gil?
It's very tricky. There are calculators out there, and you could consult with an electrician. They have calculators to be able to, you know, take a look at the actual load draw of all of your appliances and loads within the house, not just the breaker size, because the breaker size is going to be different than, you know, the actual maximum draw of that load. And yeah, so there are tools to be able to make that calculation. I would say maybe speak to an electrician. If that doesn't work, speak to a different one. But it's very nuanced, and it can be very particular to different homes. I don't know if anyone has anything to add on that.
If you're thinking of getting an electric vehicle, you may also want to consider upgrading your electrical panel so that you can install a charger. So it's an upgrade that you may want to consider for other reasons as well. So
Good point.
a factor.
Okay, I think my next question maybe is for Victor, if he's still around here somewhere. There he is.
Just answering questions in the chat.
Yeah, thank you. But we've had, you know, the perennial question of, do contractors really understand these things, and are they interested in installing them? And what's going on in the HVAC industry, Victor?
That's a great question, Brad. So I represent a cooperative of 35 HVAC contractors across Ontario. I would say that it is hit and miss across the province. And some of this kind of is historical. Contractors that have been doing work in traditional natural gas, Enbridge, or Union Gas territory, you know, have been used to installing gas appliances, gas furnaces, and air conditioners. Contractors that have been doing work in, you know, outside of traditional natural gas territory, where there's been propane or oil heat, have tended to do more heat pumps. So many of our members who've worked in rural areas have been doing heat pumps for years, and they're familiar with it. It's not a problem. Getting some contractors that consider themselves to be gas contractors first, they think of themselves as gas contractors. Yes, they are going to move more slowly towards heat pumps. But heat pumps are the largest growing segment in the HVAC business, mini splits especially. The number of heat pumps installed is growing at a very rapid pace in Ontario. And I think that, you know, progressively minded contractors are really getting on board. So if your contractor is saying they're not comfortable with heat pumps or they're poo-pooing it, I would suggest moving on. And I've included the HRAI contractor locator in a number of the Q&As. HRAI is the Heating, Refrigeration, Air Conditioning Institute. It's a nonprofit that represents manufacturers, wholesalers, and contractors across Canada. And if you go to the HRAI locator, you can specify that you're looking for a contractor that does air source or ground source heat pumps.
Great, thanks. And it's good to hear that, that it is picking up steam. Okay, so I think the next question is for Heather. And essentially the question is, if I cut off my gas service and I have a gas stove, what am I going to replace it with?
Induction all the way. Induction cookers are amazing. So I tested out an induction cooker many years ago and have never turned back. They work really well at low temperatures. They have higher temperatures. You can work faster on an induction cooker than you can on a gas stove. You don't have any indoor air quality issues from running a
an induction cooker, it is so much better than gas in so many ways. So that's my answer.
Fantastic. Sorry, I'm just quickly trying to have a look at the questions that have come in since we started this. So we're playing a little bit of catch up. There's been a few questions about the availability of water. I don't know, what do you call it? Hydronic systems, with radiators. Can I combine a heat pump with radiators?
Yeah, these systems we find are probably the more challenging, although there are solutions. So there are air to water heat pumps, which basically means, now your water is heated by a heat pump. So your hydronic system is heated by a heat pump. There are different types of distribution systems that can then work with that water. So you could have possibly a low temperature fan coil or radiator. In some cases, you don't even need low temperature as long as the capacity is there. Sorry if I'm getting too technical, but you could get these fan coils that look like radiators, look like something you might have in a hotel or commercial building, but sometimes they look a bit sleeker and nicer, and they could actually deliver the heating and cooling within different rooms. So there's a lot of different options for older radiator, boiler, hydronic homes. But it can be a little more challenging. I don't know if Victor, coming from the HVAC industry, if he has anything to add to that.
Yeah, that's great. This question's come up a lot in the Q&A. So and I've mentioned a couple of times here that air to water is in the 3rd or 4th generation in Europe, very popular in Europe where they have hydronic heating systems. Slower to come to North America just because the demand hasn't been here. I work for a wholesaler that brought in a 3rd generation system. And unfortunately, when they moved to 4th generation in Europe, there just wasn't enough critical mass for them to bring that system to North America. I think that that's shifting, and that we'll likely see more manufacturers bringing air to water systems. There's some regulatory hurdles that need to be overcome. They're not considered a federally regulated product. They need to be kind of added to Energy Efficiency Amendment 18 or 19. It's going to take a couple of years for the government to kind of catch up and regulate them federally. But we're hopeful that that's going to happen. We're lobbying the government, the industry's lobbying the government to get there. And I think that in the meantime, there are products available. So if you have a hydronic heating system and you are really interested in decarbonizing and going with an air to water heat pump, like Gil said, there are solutions that do exist. It's going to mean doing a little bit more searching for a qualified contractor who's comfortable with that technology.
Right. Thanks. A question for Heather. Indoor air quality issues, heat pump versus gas furnace, which is better?
Well, with a gas furnace, you always have to worry about leaks and carbon monoxide, and that is something that you don't have with an air source heat pump. But other than that, they're just, a heat source and then an air handler that's moving air around. So otherwise, I'm not aware of any other indoor air quality issues. And anybody else have anything to add to that?
Yeah, I'd say you could even add the benefit of outdoor air quality. I mean, if you have, your flue snorkel that everybody's used to seeing kind of on the outside of the house, I know mine was in a very unfortunate area, right next to, a patio where, I like to sit outside. And so the hot water heater is natural gas and it kind of just runs. And so, yeah, I mean, if you can electrify, then, you're getting rid of those snorkels, and yeah, no more smelly flue gas and gas smell outside.
Thanks. There's a couple of questions that sort of touch again on the clearance issue, the outdoor clearance issue from a couple of different angles. We've talked about the snow clearance. Somebody's wondering how you would possibly put this unit a meter up or more up a wall. And somebody wants to know, do I have to keep vegetation away from it? Maybe, I don't know, Gil, maybe you can answer that, or Victor?
Yeah, just very quickly, they do have mounts that just mount to like the wall, an exterior wall, and that could bring it up. In some cases, in rural areas where you have houses that are very close together, the heat pumps are actually 6 or 8 feet up in the air, so that you can actually walk under them. And so it's a non-issue, and a qualified contractor should be able to take care of that.
Okay, I'm going to pitch this one to Heather, which is, how well does a heat pump combine with solar, for instance? Can you run a heat pump with a solar system?
Well, my home is net zero, so I do have solar panels on the roof that are making as much electricity, more electricity over a year than what we use for the rest of the home. Our solar is net metering, so anytime we're making more electricity than we're using, it goes into the grid, which is the way most solar is designed. And the heat pump just runs as usual. There's no change in how that works. If you were to put in a battery or something else, then you might be able to preferentially run your systems off your own electricity, but that's another expense. Any other thoughts, Gil?
I think there's a lot of nuance to that question. I mean, off grid or not, like you say, if it's net metering, if it's grid tied, like you say, I don't really think it matters, because you're selling to the grid, or you're net metering to the grid, and then you're using your heat pump. If you're off grid, then you might be heating with wood or propane or oil possibly, and now you're switching to electricity, heat pump. That's going to add a very big load to your system, and so I'd be very careful if it's off grid, but otherwise I don't see an issue.
All right. There was actually a question about whether it made sense to switch from a wood stove to a heat pump, but I don't know whether they were off grid or not. Any thoughts on that?
Wood is an interesting heat. It's I believe it's something like depending on where you live, it could be like $300 to $400 a cord right now. It is cheaper to switch to heat pump at that cost. The other thing with wood is like, although it can be considered to be carbon neutral, the tree grows, it absorbs the carbon from the atmosphere, you burn it, it goes back. There's more to that than just that, but there's also particulates from burning wood, and smoke as well. So there's some other potential dangers. It's not just carbon neutral. There's a little more that happens there. So I would say it's beneficial if you're already looking to retrofit to a central type system. Then heat pump all the way.
Okay, and a good question about what are kind of the annual maintenance requirements on a heat pump? Victor?
Sure. Yeah. So outdoor unit, the outdoor coil needs to be clean. So typically we wash that down. We want to make sure, I think the question around vegetation was already asked, right? So we want to make sure that there aren't grass clippings being blown into the unit. We want to make sure that there aren't trees or bushes growing around the unit. So the unit should be free of any vegetation growing around it. It should be washed down. Make sure there aren't leaves on it or inside it. One thing that doesn't come up in these conversations very often, for those of you who have dogs, Keep your dogs away from your air conditioners and heat pumps. They like to pee on them. And the uric acid actually destroys the coils. So if you want to destroy your air conditioner very quickly, it's kind of, I don't know if you remember, a glass shop with a picture of a little boy with a slingshot. It said, "God bless all little boys with slingshots," because they like to, replace glass. As an air conditioning or heat pump contractor, we love dogs. When they pee on the air conditioners and heat pumps, nothing will destroy it faster than that. So keep your dogs away from if it's in the backyard. So annual maintenance for the outdoor unit that you can do as a homeowner: shut it off, wash it down, make sure the power's off before you do that. You don't want to get electrocuted. It is a good idea to have your contractor come out and check the unit each year. They'll want to check the amperage and make sure the motors are good and the compressors are good and there aren't any problems. And then on the indoor unit, again, I mean, you're changing your filter regularly. If you're using a high MERV filter, then you might be able to replace that every 3 to 6 months, depending on the number of people and animals in the home. But replacing your filter is the most important thing you can do as a homeowner. And then having the contractor, and again, once or twice a year, to clean the system if it's necessary. And literally there's a coil, a refrigerant coil, we call it an A coil, colloquially, or an evaporator coil. And that, if it gets dirty, needs to be cleaned. That's the hardest part, cleaning that in the blower. That's kind of beyond the skill set of the average homeowner, because it does require some taking apart of the unit to get in and be able to clean the coils. So those are the big things: checking pressures, checking the motors. But your contractor should be able to do that in 1 or 2 visits here.
Okay, I think we're going to do 2 more questions and then we're going to wrap up, because we are, over our hour, and we're everybody. We have a lot of great volunteer experts here. I guess maybe seeing as you're here, Victor, do you need a humidifier with a heat pump system?
Yeah, this is actually, I want to go back to the question that was asked about indoor air quality, because one of the reasons that we need a humidifier often is because the houses are leaky, they're drafty. And if you have a gas furnace that does not bring in outdoor air for combustion, Gil mentioned, the snorkel that you'll have on the outside of the house to vent the furnace. If a high efficiency furnace has been installed without a second pipe that brings combustion air into the furnace, then when you run your furnace, you're creating a negative pressure in the house. Think of it almost like a vacuum. Air needs to be sucked into the house in order to provide air for combustion, oxygen for combustion in the furnace. When that happens, we're drawing in on, the colder it is outside, the more the furnace runs, the colder, drier the air is that's being sucked into the house to make up for the air that's being combusted, the oxygen that's being combusted. That's actually the reason your house is really drying out in the winter, because you're bringing in a lot of really cold, dry air. When you run a heat pump, you're not bringing in any air for combustion. So you're not putting the house into a negative pressure, and that actually should reduce the amount of humidification that's necessary. We would actually recommend, if you're doing your air sealing, if you're doing the Greener Homes grant and you're going to make sure your house is properly sealed, that the need for a humidifier should actually go down, especially getting off the gas furnace.
Great, more good news. The next question, and again, this is a bit of a technical question, so I don't know who would be best to answer this, but there's been a few questions about pairing a heat pump with in-floor heating and how that works and whether that's a viable approach.
I think this is a similar answer to the boiler radiant in-floor question. So if you're talking about in-floor, my guess is you're talking about hydronic radiant boiler fed in-floor heating. And so again, there are solutions. There are air to water heat pumps, which then you could run that hot water, that warm water within the floor. There will need to be some HVAC and mechanical calculations done. There's going to need to be some sort of design done to make sure that the pipes in the floor have enough capacity to keep your home warm, because they were designed for a really high temperature, the boiler, and now you're going to get a slightly lower temperature with the heat pump. But I believe it's the same kind of blanket question of the boiler, hydronic, radiant heated homes. So it is possible. It's just it's a bit more complex than the systems that we talked about today.
Yeah, I would just add that we do a lot of these in geothermal systems. So when there's ground source available, and that's often again in more rural applications where we can run horizontal or lake loops. Vertical loops are possible too, really adds to the cost. But with a ground source heat pump, which is basically a water to air or water to water heat pump, we do those a lot, and they are very popular, but it is costly and not really in the mainstream of technologies at the moment.
Okay, I think we've run out of time. I'm just going to pop up a slide here with some links on it for you to all look at while we close up here. Sorry, I just messed something up here, so I will be back. And I just want to really thank our presenters and our folks who came on to answer questions. I think it's been a very informative evening, and I hope it did get you at least started on understanding what heat pumps can do. We have some links here with some more information for you to look at. And we will be posting the recording of the webinar in a day or so. We will send out the link to the recording to everybody who registered for the webinar, so you'll be getting that. And I just want to thank you all for taking the time to join us tonight, for your interest in this subject and for supporting the Clean Air Alliance. And to say that if you want to do more, you know, a donation always helps with the work that the Clean Air Alliance is doing to move Ontario to 100% renewable energy future. And you can donate on the website at cleanairalliance.org/donate. If you thought tonight was useful, that would be a great way to say thank you.